Hey, welcome. So today we're jumping into a topic that sounds super technical, but is actually at its heart incredibly intuitive. We're talking about natural logic. Basically, it's this amazing quest to get AI to understand language the way we do, not like a clunky machine, but like a person. Let's get right into it.
All right, to kick things off, just think about this sentence for a second. Most people like pizza. For us, that's a piece of cake, right? We get it instantly. But for a classic computer, that one little word, most, is a total nightmare. It isn't a hard number, it's fuzzy, it's human. And that simple problem right there, it reveals a massive challenge in AI, and it's exactly what natural logic is built to solve.
So, how in the world do you get a computer to understand something like most? Well, the answer comes from this really brilliant idea called natural logic, and what it does is pretty much flip the entire old way of thinking on its head.
Okay, the key phrase here, the absolute game changer, is operate directly. See, instead of trying to force our messy, nuanced, beautiful human language into some rigid artificial code, natural logic says, hey, let's just work with the language as it is. It actually uses the grammar and the sentence structures that we all use every single day.
And this slide just lays it out perfectly. Think about it this way. Traditional logic is like a foreign language translator. It has to hear a sentence, then stop, carefully translate it into its own special, clunky language, and only then can it start to figure out what's going on. But natural logic, oh, it's a native speaker. It just gets it. It understands the flow, the meaning, the context, right from the get-go. No awkward translation step needed. Now, to really get why being a native speaker is such a big deal, we gotta look at why that old translator method was so problematic. So let's dive into the limits of traditional formal logic. Human language is just so rich, and the old logic systems really struggled with that. They would completely trip over those wonderfully vague words like most or few or many. They'd get lost when it came to context. A word like generally can mean totally different things depending on how you say it. And this all leads to what researchers call a semantic mismatch. Basically, the translated version loses the real soul of the original sentence. It's kind of like a badly dubbed movie, you know? The words are technically there, but all the feeling is just gone.
And this quote just nails it. The old way is far from natural. It forces our language into these overly complicated, roundabout structures that just aren't efficient and, frankly, don't really capture what we mean. It's just not how people think or talk. Okay, so if the old way is out, what does the new way actually look like? This is the fun part. Let's pop open the new toolkit and see how natural logic actually gets this done. So this isn't just one single thing. It's more like a whole collection of really smart systems. You've got stuff like monotonicity calculus. Sounds complicated, I know, but the idea behind it is super intuitive, as you'll see. Then there's fuzzy natural logic, which is specifically designed to finally handle those tricky words like many. The point is, each of these tools is custom built to work with language's own rules. Let's make this real with a quick, simple example of that monotonicity thing I mentioned. Check this out. If we know that the statement, all corgis bark loudly is true, well, then it's a pretty safe bet that all corgis make noise is also true, right? Because making noise is a bigger, broader category that barking loudly fits inside of. That's it. It's called an upward inference, and it's the type of reasoning that feels totally natural to us because it's how our brains work. Natural logic just builds that same common sense right into the machine. Okay, this is all fascinating stuff, but what's the point? Why does any of this matter in the real world? Well, turns out this whole new toolkit is already quietly running behind the scenes, powering some of the tech you probably use every day. Yeah, this isn't just theory. Natural logic is the engine behind what's called textual entailment, which is just a fancy way of saying it can figure out if one sentence logically follows from another. It's what helps Siri and Alexa not just hear your words, but actually understand what you mean. It is making the entire field of natural language processing smarter, faster, and way more human. And here's a really important, kind of technical goal. The whole point is to build systems with a decidable validity problem. All that really means is that the computer can always give you a straight answer. It can always figure out if an argument is valid or not without getting stuck in some endless loop. This makes these systems incredibly reliable and super efficient. They don't guess, they just deliver an answer. And that really brings us to the big final thought here. For decades, we tried to make computers learn some new, totally artificial language. And now,
Now we're finally teaching them to speak ours. We've gone from that slow, clunky translator to a fluent native speaker. So the question we're left with is a pretty exciting one. If our technology can finally truly understand us, what amazing things are we going to ask it to do next?